Now, it has been about 2 years since the 40 series from Nvidia has released, so there is no question that there was a lot of anticipation and excitement around the next generation of graphics cards coming from Nvidia. Now, with the release of that, people were looking to see how these cards will perform in terms of AI and in terms of graphical fidelity for these next generation of cards. Now, with the new cards, there seems to always be some issues that pop up, and as well as some issues that continue to plague Nvidia GPU cards. So in this video, we're going to take a look at what some of those issues are, as well as take a look at what could be the possible causes of some of those issues. But before we dive deep into all that, if you're new to this channel and enjoy staying up to date with the latest tech news, you've landed at the right place. Do me a huge favor, hit that subscribe button, hit that notification bell, and hit that like button if you enjoy this video. All right, let's take a look at this. Nvidia's RTX 5000 cards now show PCB hotspots that threaten longevity, says Igor's lab. Now, this is an article out of techspot.com. So let's go through this article real quick. Igor Walasek of Igor's lab has discovered a problem that appears to be present in most Blackwell AIB partner cards. Local hotspots at the rear of the PCBs. This could potentially lead to the cards being damaged over time due to heavy use. As you can see from this picture right here, let's see the thermal imaging here. You see the temperatures on the different spots of the card, how it is tends to be higher on the end of the card here, as the article does point out. So let's continue. During a sustained torture loop, a PNY RTX 5070 overclock and a Palette RTX 5080 Gaming Pro overclock, Walasek recorded temperature spikes in the power delivery areas of the cards. The RTX 5070 reached 107 degrees Celsius, while GPU core sat at a much cooler 70 degrees Celsius, and the 5080 Gaming Pro overclock peaked at 80.5 Celsius. So 107 degrees Celsius, that is equivalent to over 220 degrees Fahrenheit. So that is actually pretty high for any component in your computer to be reaching. Walasek writes that the problem lies with the tightly clustered arrangement of FET chokes, drivers, and via arrays in the area that funnels hundreds of amps through a postage-sized stamp patch of copper layers. PCB traces only 35 to 70 microns thick, must share the load through stacked power planes, concentrating heat vertically and laterally. Walasek also points to shortcomings in Nvidia's thermal design guide made available to all manufacturers of AIB cards and components. Igor's quick and dirty fix, adding a strip of thermal putty and a thicker pad to bridge the hotspot to the back plate, led to significant temperature reductions. The RTX 5080's hotspot dropped from 80.5 Celsius to 70.3 Celsius, while the RTX 5070 dropped from 107.3 degrees Celsius, again that's over 200 degrees, to well below 95 degrees Celsius, which is still quite high. Again, that's still over 200 degrees in total. So one question I have to ask is, if this hot fix works, why was this something that Nvidia did not factor into the board's manufacturing process? But we'll touch back on that a little bit later. Let's go over here. There's another issue that is still plaguing this. So besides the fact from the PCBs themselves running super hot, Gigabyte RTX 50 series GPUs reportedly prone to melting thermal gel issues. And this is a story out of Tom's Hardware. According to a discussion thread on Quasar Zone, one user noticed thermal gel oozing out of their 1-month-old RTX 5080 GPU. The user reported playing WoW or World of Warcraft for 2 hours daily. Notably, the GPU was mounted vertically using a riser kit. While this could have been an isolated incident, further comments in the thread suggest that melting thermal gel issues is also affecting other Gigabyte models, including the Gaming OC, WindForce, and Aorus Master Series. So it looks like this could be a problem isolated to just the Gigabyte cards, but I still wanted to talk about this because it is affecting the 50 series cards. So right now I say it's just Gigabyte. I haven't heard anything about any other manufacturers that could be having this problem. I'll quickly show you a picture to show you what exactly is happening. Gigabyte launched its RTX 50 series lineup with server grade thermal conductive gel in place of traditional thermal pads. The company claims this material provides better heat dissipation efficiency without shifting for long-term usage. However, it's possible that Gigabyte didn't fully account for vertical mounting, although thermal gel is typically non-conductive and considered safe in most scenarios. So we go over here to the form here, we can see what is actually happening here. So you can see this little gray stuff right here. I have my mouse kind of circling. It's oozing out from or onto the graphics card itself. So you can see here, that's one picture here, and then you can see another picture here. You can just see this just kind of oozing out. So again, this right now is affecting just the Gigabyte cards. Seems like I said a number of the Gigabyte cards, but this is something that would suck, that you only had your card for a month or two and you starting to see this ooze come out. Now I think the quick and dirty solution to that is just to clean it out. It's saying that it should not affect the performance of the card, but again, that is not something that you would want to see in your graphics cards, especially only after a month or two, something like that oozing out, especially if you're one of those who actually like to display your computer innards to the world. You don't definitely want something like that showing up. That looks kind of messy and looks nasty. But again, there's still one more issue that is still, and this is an issue that was plaguing the 4000 series cards. MSI secure yellow tip RTX 5090 12 volt 2x6 cable is still vulnerable to melting. Now, we all remember what happened with the 4000 cards, that their power cables were melting. I discussed that, probably a year ago. Again, this is an article out of Time Hardware. A user at Quasar Zone reported thermal damage on MSI prevented yellow tip 12 volt 2x6 power cables, which were originally meant to simplify cable seating and prevent melting. Prevent melting? Well, that is not happening. That is not actually fixing the problem. It's still happening. As you can see here on this picture here, you can see a little brown spots on some of the pins here. Definitely some melting issues. RTX 50 GPUs draw power through the 6 12 volt terminals on the 12 volt 2x6 connector, each with a strict current limit of 9.5 ampere. Naturally, GPUs have low balancing capabilities, but reference RTX 50 models are unable to determine per pin current measurements, preventing effective load distribution across the pins, and that's a design choice made by Nvidia. Consequently, a poor connection on some pins forced the entire load through the correctly seated ones. Several reviewers have witnessed this firsthand, with individual pins spiking to more than 150 degrees Celsius. So that's well over, what, 320 degrees or something? That is just ridiculous, that heat problem there. Continue on here. ASUS Astro works around that by including a series of shunt resistors that alert users if a specific pin is drawing excessive current. The Zotac safety light mechanism is also a noteworthy mention, as it prevents your GPU from powering on if the cable isn't inserted properly. So it's good to have these type of measurements here, but again, this is something that is plagued the 4000 cards, and it's plaguing the 5000 card. So again, Nvidia is overlooking this problem. So one of the things I want to talk about is what could be causing this problem. As you know, Nvidia makes most of their money from the AI cards, from the AI GPUs. That's where they make all their bread and butter from. So, and we know that the 5000 cards are based off the Blackwell, which is the same architecture that is used in their data center GPUs, which is used for AI handling. So I guess that begs the question, were these cards, did quality assurance not catch this problem? It's possible. You would think that the amount of money that they're spending on R&D and quality assurance, that some of these issues could have been captured in that process, especially the issues with the power cord melting. We had that issue already, and it's really puzzling that this is still happening on the 5000 cards. The other issue is the design of these cards. So again, the Blackwell are designed for a data center, which has a very different architecture for cooling the whole room and all the architecture and infrastructure in there. Was that something that was overlooked by Nvidia and didn't factor into how somebody who's sitting at home in their basement or in their office in the living room, how that the heat dissipation would not be the same, or the heat management wouldn't be the same as compared to what's in the data center? Because if you've seen a data center or actually been in a data center, very cold in there, so which would help all the components just to stay at an even temperature. So maybe that's something that Nvidia overlooked with the design of the Blackwell cards. That is something for Nvidia to come out and talk about. I haven't heard anything from Nvidia about the current issues and what they plan to do to address those. But what do you guys think about this issue that is going on with Nvidia? Do you think this is something that's going to continue to plague them, or is this something that they can get a handle on and try to fix this as soon as possible? I don't know if they're going to be able to, well, new cars that were being manufactured, they should be able to retrofit those and address this problem. Or have you come across this problem with any of your GPU cards, especially the 50,000, the 5,000 series? Let me know down in the comment section. Definitely want to see what your thoughts are. Once again, thank you guys for taking time out to watch this video. Again, if you enjoy staying up to date with the latest tech news, do me a huge favor, hit that subscribe button, hit that notification bell, and hit that like button if you enjoyed this video. Also, chances are, if you enjoy this type of content, you may have friends or family that enjoy this, so make sure you share this with them. And if you want to stay up to date with the latest tech news, head over to sounds30.com, where I curate and aggregate tech news from around the web, covering Apple, Samsung, Google, Android, computing, and even more general tech news, all at the website sounds30.com. And for even more tech news in video form, check out one of these two videos right here. Until next video, guys, stay nerdy.